Hello student. Dear student, today start a new chapter. It is a very most or important because with the help of this chapter we know that the properties of elements are character of the elements and also comparing or similarities or difference everything. So our chapter name is classification of elements and periodicity in the properties of chapter 3. So in this chapter especially we distribute the elements according to their character. So the main question, why we distribute, why are classify the elements? And the answer is because we better know the character or properties of an element, so we classify. And this chapter in our syllabus we discuss to many more topics or many more law of or principle represented by different scientists. So the first, let's recall and revise law of traits. So according to the law of traits, elements were placed in a group of 3 and they were called traits, and these were placed in an increasing order there of atomic masses, and these traits represented by Dovenier. And actually Dovenier make a set, and each set present 3 numbers of elements, means the total elements present in every set or each set in 3. And also to find the atomic mass of elements number 2 of each set, so Dovenier do a thing, he added two elements atomic masses of elements number 1 and 3 and divided by 2, and according to these traits this is the atomic mass of elements number 2 approximately value. But the drawbacks of this set or this traits, this set only apply to some few elements, means only made 4 or 5 set, and rest of elements this set are not applicable. So this is the law of traits. The second point or second person who represent the distribution of an elements according to their atomic masses, Newland's. So Newland's law of octavates. So octavates, that means our music rhymes especially depend to the sa, re, ga, ma, pa, dha, ni, and again sa. So the elements were placed in increasing order of their atomic weight, and it was noted that every eighth elements had properties similar to the first elements, and the relationship was just like every eighth. Note that resemble of first in octavates of music. Newland's law of octavates seemed to be true to the elements only up to calcium. It means it's also the law depend to the atomic weighted, and the drawbacks. So these types of law applicable only few elements, especially in up to calcium. So up to calcium elements arrange according to their atomic weighted in rhymes sare gamma pa dha ni and again sa, means the elements number 1 2 3 4 5 6 7 present in a straight line, and eighth number elements put up in downside of first elements. 9 is second, 10 is third, 11th is fourth, 12th is 5, 13 is 6, and 14 in 7. And according to this law, the properties of elements number 1 and 8th, 2 and 9, 3 and 10th, 4, 11th, 5th, 12th, 6th, 13, and 7, 14 means this all elements to downside presents means 1, 8, 2, 9. So 1 and 8th elements, the properties are similar. 2 and 9, the properties are similar. 3 and 10 are properties are similar. 4, 11, 5, 12, 6, 13, and 7, 14. So these elements are similar according to this law. But this law only applicable for some elements, not whole elements. So this is the Newland's law of octavets. This is the uh, table. First, this is the Dovenier traits: lithium, sodium, one row, and second calcium, strontium, barium, and next chlorine, bromine, and iodine. And this is the Newland octavets: sa, re, ga, ma, pa, dha, ni. And according to sa means do, re, my, fa, so, la, ti. So according to Newland's octavets, in the first row means hydrogen, fluorine, chlorine, cobalt and nickel and barium, Re, lithium, sodium, potassium, copper, rubidium, and Ga, beryllium, magnesium, calcium, zinc, strontium, and Ma, barium, boron, aluminum, chromium. So this all types of elements means every row the elements are present like that. Here 5, here 5, here 5, 5, 5, 4, and 4. So according to this law, this all types of elements properties are similar. So this is the Newland octavet rules. And next video we discuss to a graph to distribute the elements according to their atomic masses. Okay, thank you.